In this video, we're going to talk about the polar jet stream and some of its common characteristics, as well as a cross-section to identify kind of where in the vertical this might occur, along with other features that we've been talking about through the course of this semester. So the polar jet is probably the most common jet stream that we can talk about here in synoptic meteorology. The polar jet generally occurs just below the tropopause. That's because just below the tropopause, around 200 to 300 millibars, or 200 to 300 hectopascals, is where we see the greatest slope in the tropopause, which is the largest factor in the placement of our polar jet stream. And that's because polar jet streams occur as the result of low-level temperature gradients. And so one way to distinguish a polar jet stream from other jet streams we'll talk about in different videos is understanding whether or not a jet stream is associated with a strong low-level temperature gradient. Our polar jets can have wind speeds on the order of 50 to 75 plus meters per second. They can get much stronger during our winter months when we tend to have the strongest possible jet streams. The stability surrounding these jet streams is that it'll be stable on the poleward side, or on the cold side, of our jet stream. Highest static stability. On cold side of jet, and this is owing to thermal wind balance. Right, where we know that cold air should be on the left-hand side of the jet. And so in the northern hemisphere, this is to the north. And of course, that is where then we are going to have a lower troposphere. And so most of our classic mid-latitude cyclones are going to be associated with very strong polar jet streams. So let's go ahead and take a look at a cross-section of the polar jet stream to see kind of what we mean by this highest static stability on the cold side, occurring right around 200-300 hectopascals in association with the tropopause as a result of low-level temperature gradients. Our cross-section can kind of demonstrate all of these things individually. And so here's an example of a cross-section. And so I'm going to go ahead and annotate this just a little bit. And so our solid black line here, which I'm going to double highlight, is our tropopause. Right, and so it's this area up in the upper parts of the atmosphere. This is our dynamic tropopause, or DT. And we see that we have a large inflection here, or a large change in the height of the tropopause. Our pressure levels are indicated on the side, and so where our tropopause is higher, we can generally tell that the average temperature of the layer is warmer, and so we could indicate that we have generally warm air down here. And then to the north, we have generally cold air with a shallower tropopause. And so it turns out that our jet streak is right here in the middle of this 80 meter per second contour. This is our jet. And we could even shade in some values here, right, such that we have our main jet streak here, and then surrounding it, we have our weaker jet, but still a jet stream here. And so that's our jet. And so what we're seeing here is the consequence of the strength in our temperature gradient in the lowest levels being in this area. Strong delta T, del T. Because that strong change in temperature is what is then causing our large change in the slope of our tropopause, such that here our isentropes are in the dashed black contours with the values signified here. And so we see that this area to our north here is relatively high static stability. And then in the troposphere, we have generally lower static stability. And again, that is known by the spacing between our isotopes here. When they're really close together, this is very stable air. And when they're farther apart, this is less stable air. And so we see that in this situation, we have wind that is coming out of the page towards us. And so we could draw in our classic notation here, out of the page towards us. It's with a dot and our circle coming out of the page towards us. This is a classic upper level polar jet stream occurring between that 300 to 200 hectopascal level that can occur any time of year, but probably most prominently during our northern hemisphere winter, and we could do a similar thing for a southern hemispheric winter. And so that's polar jet streams. We'll talk about our other types of jets in other videos. Thanks for watching.